Okay, today's lesson is going to work with learning target 3.4. It says I can use scale drawings to compute actual lengths and areas. Okay, so we're going to talk about similarity in scale drawings. So, similar figures. Figures are similar if they are the same shape but not the same size. So they have this same shape, but not the same size. So these figures down here, they look the same, but one is stretched out or shrunk. The corresponding angle measures are equal, and the corresponding side lengths are proportional. So we're going to use our solving proportions to help us with these. Okay, so let's go ahead and take a look at some of the different problems here. Okay, pentagon. Our pentagon EFGHI is similar to the pentagon RSTUV. So these are similar. They're telling us that they're similar. That is important to know. Now we can label, we can label the corresponding angles. So the angles are going to correspond in the order that they did up here. I always tell students this helps them out. We're going to rewrite this. It's E, F, G, H, I, straight from my problem. Then I'm going to write this one just exactly how it comes, R, S, T, U, and V. So they have corresponding angles there. So angle E, that's an angle symbol there. Angle E is equal to angle, or corresponds with angle R. Okay, angle F corresponds with or is equal to, I'll put 2 marks in this one because that one's different, angle S. Angle G corresponds to, put 3 there, angle T. Angle H corresponds to angle U. Again, we're just following these. Okay, and then last but not least, angle I corresponds or is equal to angle V. Again, we took it from here. Okay, so when they list them out, it gives us the order. That tells us the order. And it's going to be similar here when we talk about sides that are proportional. We're just talking about what corresponds with each other. Again, I would recommend that you write them out. So I have parallelogram JKLM is similar. They told us that it's similar to parallelogram WXYZ. Okay, so we're going to figure out what corresponds to each other. So we're going to start here. Sides should be 2 letters. So if we talk about these two, side JK here, corresponds to side WX. And it's not the way that it's sitting, it's the fact that these letters are together. Okay, and then we have KL here, side KL, and side XY. Okay, so K to L is, we'll put 1 mark there. X to Y, we'll put 1 mark there. That means those kind of, we're talking about those corresponding. Okay, and then we have LM and YZ. They should go in the same order also. And then last but certainly not least, we have MJ or JM. We'll go M to J. And since we went M to J, we'll go Z to W. These should have lines over it because we're talking about sides there that correspond. Okay. So next we're going to get into scale factor. Okay, so for scale factor, it's how much bigger or smaller your object is going to get. So scale factor is the ratio of corresponding sides in a figure. So this is really important that you're looking at it this way. It's new over original. So the new shape, the new side is on top, the original is on bottom. Our scale factor that's greater than 1 indicates an enlargement. Now, a scale factor that is less than 1 is a reduction, or it shrinks. For figures to be similar, they must have the same ratio or scale factor. Okay? So let's go ahead and look here. It says the photo below is being enlarged to form a 16 by 20 inch print. What's the scale factor being used to enlarge it? You could draw out a picture if that helps you. Okay, it's certainly not going to hurt. If we draw out a picture, let's say it's 16 by 20. And if you're going, okay, not quite sure which numbers to use. Here we go. So it doesn't really matter which one you pick to use. Sorry about that. So if I pick, let's say I pick the 5 here. Since 5 is bigger than 4, I'm going to pick the 20 since 20 is bigger than 16. Nothing special about that, just if they're both the bigger numbers or both the smaller numbers. On the top, we want new over original. So it says the photo is being enlarged to form 16 by 20. So the 20 is the new one, and the 5 inches is the original shape. Then we're going to go ahead and divide that out or put that in our calculator. And our scale factor here is going to be 4. Now, if we were to take the other sides, the two smaller sides, the new one is 16. The original is 4. 16 divided by 4 is still 4. So my scale factor should not change ever, no matter which one I try. So let's try them both sides. Okay, the map is being reduced, which means it's going to get smaller to form a pocket-sized version. What's the scale factor being used to reduce the map? So 24, which is the bigger number, goes with the 6. And then we have the 14 goes with the 3.5. So the new one is the reduced one. That's the smaller one. So that's going to be 6 over 24, which becomes 1/4. Okay. If we do 3.5, the new one over the original, it still is going to equal 1/4. Okay, so my scale factor here is 1/4. Okay, we can leave it like that. If you go 0.25, that would also work. 1/4 is 0.25. Okay, so now let's scale drawings on the next page. So scale drawings, it's a 2 or 3 dimensional objects that can be represented with a scale drawing or a scale model. Okay, so some good examples, like a map. A map is a great example you've seen plenty of for scale drawing. A photo could be a scale drawing because we can make that bigger or make that smaller. Okay, blueprints, shadows and objects, like Hot Wheels cars. Those are actually to scale. A lot of architects we use like a model, and that model is to scale, so they just blow it up, make it bigger. Okay, so we talk about scale factor here. We use the scale factor to enlarge or reduce the triangle. So if my scale factor is 3, okay, if I'm looking at side AB, okay, so I'll use this for side AB. We'll go BC is here, and we'll go CA is this side. I'll try to color code this for you. So we're going to multiply it by 3 is what's going to happen. So you're going to take your 5, multiply it by 3, and I get 9. And then that's going to be centimeters. Make sure you have your labels. Now my scale factor here on the last one is 15. I'm sorry, 1.5. So we're going to multiply by 1.5. That's what the scale factor happens. So if I do CA here, it's 12. 12 times 1.5 is 18 centimeters. Okay. Now I can also work backwards. So here, if I look at 9 centimeters, that's my new one. Okay, remember we're going to go new over original, so it spells no. Okay, so new is 9, the original one's 12. I'm going to put that in my calculator, and it's going to simplify it for me. So my scale factor here in this one is actually 3/4. Okay, so then I would multiply the blue side by 3/4. Okay, so this one, they want you to draw out a triangle similar to that triangle. And then it's going to be called P prime, Q prime, R prime. The little marks mean prime. That's just meaning that's your new version. If my scale factor here, it says the triangle PQR is shown below. Its original lengths are multiplied by 2.5. What are the new sides? So what you're going to do is you're going to take this side here and multiply it by 2.5. And you're going to get 20 centimeters. Okay, we want you to finish that off for the whole thing. All right, number 7 here, rectangle ABCD has been enlarged to form rectangle A prime, B prime, C prime, D prime. What is the scale factor? So this is the new one. Okay, so you're going to pick a side. Doesn't matter which side. Remember, again, we're going to go new over original. So let's say I just picked this top side here. 18.6 is the new one. The original one from A to D is this side here, which is divided by 6.2. So when I put that in my calculator, my scale factor here is 3. Okay. These last two. So you're going to set up a proportion to solve for missing parts. We're going to set them up accordingly. So this side matches this side. The bottom side here matches this bottom side. So what's going to happen is we're going to set up a proportion across multiply and solve, which you guys are doing awesome with. The purple ones go here. The pink ones are going to go here. Okay. You generally set it up as new over original. I'm going to be honest, it doesn't matter as long as you start with the same one. So we're going to go 6 over 9 is equal to x. I go back over here because I started with the 6 over 15. Okay, you're going to cross multiply and solve. All right. Similar idea here, set up a proportion. Susie walks 1.5 miles to school. When she looks at the map, the scale is 1 centimeter to half a mile. What is the distance between her and her house? I would pick and go maybe miles over centimeters or vice versa and set it up, cross multiply and solve. Okay, so from there, that's our notes. You have a little bit to work on and finish up here on scale drawings. Remember that our learning target here today was I can use scale drawings to compute actual lengths of area. And that's what we're doing here at the bottom, especially computing that. We had to make our way to that. Let us know if you have any questions.